Alright, so now we're going to talk about factorials. For positive integer n, the notation n with an exclamation point is read n factorial, and is called the factorial of n, and represents the product of the numbers in the set 1, 2, 3, all the way up to n. That is with the exception of 0 factorial, which is defined to be 1. So basically, we have the definition of 0 factorial to equal 1, but then any other factorial, n factorial, is 1 times 2 times 3 all the way up to n. And because, of course, multiplication is commutative, some books list it as n times n minus 1 times n minus 2 all the way down to 1. So either one of those is equivalent. It's multiplying all the numbers from 1 up to n. Alright, so here is a nth term of a sequence, and they're asking us to find the first 5 terms of this sequence with this given nth term. But you notice that the nth term has a factorial in it. So let's go ahead and find this, the first 5 terms of this sequence. Well, let me see. So A1. Well, A1 is defined to be 3 to the power of 1 over 1 plus 1 factorial. So that's how we're going to find A1. And let me see, that's going to be A1 then is equal to 3 over 2 factorial. But 2 factorial is 1 times 2. So therefore, this is just 3 over 2. 3 over 2. All right. So that's the first term. Not too bad. Now, to find the second term, well, A2. So that means we're replacing those with 2's. So A2 is equal to 3 squared divided by, oh, not 3, my fault, is equal to 2 squared, because n is 2, and that's divided by 2 plus 1 factorial. So that's equal to 3 squared is 9, and 9 over 2 plus 1 factorial is 9 over 3 factorial. And 3 factorial is 1 times 2 times 3. 1 times 2 times 3 is 6. And 9 over 6 reduces to 3 over 2. So the second term is also 3 over 2. First 2 terms are identical here. Alright, so the next one we're going to find, we're looking for now A3. Well, let me see. A3, we just replace all those with 3's. A3 is 3 to the third over 3 plus 1 factorial. And that's going to give us 27 over 4 factorial. Well, 4 factorial is 1 times 2 times 3 times 4. And we simplify this. For instance, 3 goes into 27 9 times, so we can cancel that factor. And we'll get 9 over 4 times 2, 8. So that the third term, A3, is actually 9/8. 9/8, that's not too bad. So let me see. The next one we're looking for is A4. So A4, we just replace all those with 4's. A4. So 3 to the 4th power is 81. 4 plus 1 is 5, so that's 5 factorial. And this is 81 times 1 times 2 times 3 times 4 times 5. And we can simplify. For instance, 3 goes into 81 27 times. So the result then is 27 over 5 times 4 is 20. 20 times 2 is 40. So the fourth term, A4, is 27 over 40. All right, moving right along. We only have one more to go. The fifth term. Let's see, what's the fifth term? The fifth term, we just replace those with 5's. The fifth term is 3 to the 5th power over 5 plus 1 factorial. 3 to the 5th power is 243 over 6 factorial. So that's 243 over 1 times 2 times 3 times 4 times 5 times 6. And this can be simplified. For instance, 3 goes into 243 81 times. Oh, there's also a 3 in 6. That 3 goes into 81 27 times. So what I have left over is 27 over, let me see, 2 times 5 is 10. 10 times 4 is 40, and 40 times 2 is 80. So the last term, A5, that I'm looking for, turns out to be just 27 over 80. And there are the first 5 terms of that sequence defined with a factorial. Here's a second example. Evaluate the factorial of the expression. Oh, and there's a typo here. This should be 17 factorial over 4 factorial times 13 factorial. So let's expand that and take a look. So 17 factorial. 17 factorial is 1 times 2 times 3, and I put ellipses to show all the ones in the middle. And we are going to pick it back up with 13. 13 times 14 times 15 times 16 times 17. So that on top represents 17 factorial. I skipped the ones, I didn't write them all out, but those ellipses mean they continue like that in the middle. Then we have 4 factorial. 4 factorial is 1 times 2 times 3 times 4. And we also have 13 factorial, which is, well, let's see, that's 1 times 2 times 3, and then we stop at 13. And that's why I expanded the numerator the way I did, 17 factorial, because this 1 through 13, these factors 1 through 13, will just cancel with the factors 1 through 13 on top. And you'll be left with just 14 times 15 times 16 times 17 over 1 times 2 times 3 times 4. Some of that can be simplified. For instance, 2 has a common factor with 14, leaving only a factor of 7 in the numerator. 3 has a common factor with 15, leaving only a factor of 5 in the numerator. And 4 has a common factor with 16, leaving only a factor of 4 in the denominator. So that whole expression can be simplified as just 7 times 5 times 4 times 17. And that product is the final result. So we have, let's see, that's 7 times 5 is 35, times 4 is 140, times 17 is 2,380. So the result here is 2,380. So that's what that expression is equal to. And the last one, evaluate the factorial expression. Well, let's see. We do this one the same way we did the last one. We're going to expand it and then cancel out common factors. So for instance, in the numerator, I have 1 times 2 times 3 all the way up to n. While in the denominator, there are more factors. There are exactly 2 more factors, because you have your 1 times 2 times 3 all the way up to n, but then there's n plus 1 as a factor also, and the last factor is n plus 2. So I have all those factors, and then a bunch of them cancel. The 1 through n cancels. So the numerator, there's no factor left except a factor of 1. And the denominator, I have 2 factors, n plus 1 and n plus 2. And there's your final result. So that's how we evaluate factorial expressions.